Hello again, ladies and gentlemen. I am the heavy metal chemist, here to do another lecture-y type thing for you. It's going to be a fairly quick one because I'm full of a cold at the moment, and it's a fairly quick topic anyway. So what I'm going to talk about today is the fundamental states of matter. It's a fairly simple thing, but it's quite interesting nonetheless, especially when you get into some of the kind of intermediate states which are not often talked about. So if we draw ourselves a graph, we'll have temperature there, pressure there, with absolute zero down yon. And basically, what we have is, if I draw a line like that, and a line like that, and we go solid, liquid, gas, like so. Now there's a number of important little points on here. I can extend that up a bit, that goes upwards. Here we have what is called the triple point, the point at which, in temperature and pressure, a compound or element will quite easily change from solid to liquid to gas, depending on slight changes in either temperature or pressure, which is actually quite what happens on the surface of Mars for water, which is quite interesting. And the other one is here, which is at what's called the critical point. Now, beyond this, as you kind of go this way, the boundaries between liquid and gas start to merge, and you end up with some kind of weird properties of like, say, water, which mimic both liquid and gas, so it expands to fill volume like a gas. It won't sit at the bottom under gravity, but at the same time it's got density more like liquid water. It's about 100 kilograms per cubic meter rather than about 1 for steam. So the critical point is here, that was CP, and triple point is there. And again, as you kind of go really high in temperature, we'll draw a crude line here, beyond which we get plasma, which is when the atoms and compounds start to fall apart and all kinds of crazy shit happens. That's the essence of it, really. The changes between these things are quite commonly known. So that one is melting and freezing. Here we have evaporation and condensation, and here we have sublimation and deposition. And then plasma's ionization and deionization. And the critical point, you can basically just heat things up and under pressure, and they'll go beyond the critical point and then cool them down, and they'll go subcritical again. This kind of technique's used in some kinds of research for extraction of caffeine from coffee to make decaffeinated coffee, for instance, and things like that. So it's used quite commonly. Supercritical CO2. CO2 is actually quite an interesting compound, because if you look on this kind of thing, it doesn't actually have a liquid phase at room temperature. So basically, the pressure for CO2 would look something a bit like that at room ambient pressure, whereas water is kind of up here. So as you heat it up, you go from ice to water to steam. CO2 will just go straight from dry ice, solid CO2, to gaseous CO2. You've got to pressurize it to about 7 atmospheres, I think it is, before you can get a liquid, and then it'll turn into a supercritical fluid at around about 30 degrees. So that's how they managed to do that. It's under 70 atmospheres and 30 degrees. The critical point of water is 219 atmospheres and 374 degrees C. So that's a much higher critical point, but it's still attainable with reasonable equipment. Because some groups do look at that in research. I've done it myself a while back. That's the essence of it, really. It's quite a simple little thing, but I hope that's added a little bit of entertainment to your evening. And do like the video, subscribe to the channel, and get in contact with me via the comments or messaging if you have any suggestions of videos that you want me to cover or similar kinds of thing. Thank you, and good night.